Welcome back to the Graph Traversal algorithm implementation and Graph DFS implementation. The project exercise is done using a web-based system implementation and a command line interface implementation. The code is stored on my GitHub page. You can find that in this video's description. You can download it if you would like. Follow the README file in the code on GitHub to install and to prepare your system to host the program. This is my GitHub page. This is the code that has all the implementations, the graphical user implementation and the command line implementation. You just follow this README file. It tells you how to install and how to use the command line interface version of the code. Let's take a look at how to implement the command line version. Open your CMD, that is your command line, and after installing the software, the project, the way it is instructed in GitHub, then you can come into command line and just cd into the folder. The virtual environment folder is in your GitHub instruction. I'll just do that here. Graph DSA, and in Graph DSA I'm going to activate my virtual environment, and from that I'm going to go to Graph DSA folder. The Graph DSA folder is where I have my project stored. So let me clear the screen again, and I'm going to run the code. The code is stored. I'm going to run the code by typing Python utils / okay, let me show you the code. The code is stored for graphical implementation, is stored in the utils folder. So let me show you what is in the utils folder. So for the command line implementation, it's a CMD view. So I'm going to say Python utils CMD views, and it's going to run the code for me. I am here in the code for the user interface, the command line user interface, and you can see it has 8 items on the menu. The first is to add a node, and then the second to print, and you can see all the rest. You can also connect nodes that you've added. You can show those nodes, you can disconnect a node, you can remove a node or delete a node. You can also show the diagram of the node, and then of course the depth first search, which is our assignment. Let's start with the first item, which is you enter 1. What do you want to do? Enter the number. So I'm going to enter 1. It's going to ask me what node I want to enter. So here I can say enter a node. So the graph I want to create is for locations. I'm just going to use location as my graph type. So I'll say Lagos and say Ogun and Oyo and Kwara, Kogi, Nasarawa, Kaduna, Bayelsa, Rivers. So when I'm done, I'll just enter. I won't enter any other name. I'll just press enter, and then it returns me to the main menu. Now in the main menu, the second item is print all nodes. So if you press 2, it's going to show you all the nodes that we just entered. We have Lagos, all those nodes are printed out for you. On pressing any key, it returns you back to the main menu. Now if we want to connect nodes, we created all those nodes. If you look at 2, Lagos, Ogun, Oyo, Kwara, and all that. So if you want to connect nodes, you can use the third item on the menu, connect node. So I can say I'm connecting Lagos to Ogun, and I'm giving it a weight, say 1,000. That weight may be the distance, the kilometer distance, whatever you want the weight to be. And then it asks me again if I want to connect another node. I can say Lagos to Oyo node. Just put in some data. Lagos to Kaduna. Put in some value. Kogi to Nasarawa. Put in some value, and if you're done, you can just press enter. So it's going to bring you back to the main menu, and you can show the connections. You know, we've done some connections, and we want to see how all the nodes that we've created, how they connect to each other. You can do that with the menu item 4, and this is going to show you Lagos is connected to Kaduna, Ogun, and Oyo. Oyo doesn't have any connection. You know, Ogun doesn't have, Kwara doesn't have, Kogi has just one connection. Let's add Kogi to Ogun. That will be connections 3. Kogi connects to Ogun, and that will be, you know, just give it some value. If you go check it again, you will see that Kogi now has Ogun connected to it. So let's add Kaduna and Bayelsa to Nasarawa. So this is basically just adding stuff together. Kaduna, give it some value. Nasarawa, Bayelsa, give it some value. And another good thing with this item number 3 is that those nodes does not have to exist before you connect them. So the moment you create, you mention a node that doesn't exist, it actually runs item number 1 to add the node and then connect it. So I can say Gusau. I'm connecting Gusau to Kano. I know Kano exists, but Gusau doesn't exist. It's going to accept it. It's going to create a new item, a new node, Gusau, and it's going to connect it. So basically, you can jump creating nodes and just go to number 3 to just do the connections. As you're doing the connection, is creating the nodes. So let's take a look at it again. Number 4, show connections, and you can see Gusau is here. Gusau is connected to Kano. Rivers doesn't have any connection. Let's you know, you can just do all this just whatever way you want to do it, and you're gonna get all the connections you need. I have in the code some connections I have already done. I've had coded so that it will be easy to navigate through this menu and not spend so much time creating connections. I'm just going to show you the code right now and show you how those connections are made. So here is a portion of the code. I'm just going to I'm not going to go through the intricacies of the code in this video. I just want to remove this, uncomment these items. These items basically is what does the connection. I did it so that I would not have to start typing, to make this video not get too long. A disadvantage of using this command line interface is that it's not storing those connections in a database. I purposely did it that way so that we can see how this works. And anytime you exit, 9 is to exit, all the connections you made will go off. So the hard coding we did here, the hard coding is going to help us to be able to view the codes. I mean, we will not need to do all those entry again. So I'm just going to connect again to the application, Python utils. So I'm right here now, and I have some connections already done for me, hard coded for me. If you want to see the connections, you go to 4, show connections, and you can see these are all connected. They've all been done. Lagos is connected to Anambra, Abia, and all that. And what can we do? We can also disconnect a node. We can disconnect a node. You know, these are all connected. I can disconnect Lagos from Abia. Let's do that. So I will say 5 to disconnect a node. It tells me from where? Lagos, Abia. So it's going to say Lagos, route Lagos to Abia is being disconnected. So if you want to get out of this, just press enter. It takes you back. So if you do 4 to show the connections, you will see here it used to be Anambra, Abia, and Kano, but now it's just Anambra and Kano. I'm just going to run this code again. I'm going to exit and run the code again from the beginning so that we can have all the parts there. If you say 4, you'll see Abia is here, Rivers has Lagos. So that being done, we can show diagram. I'm jumping node. It's similar to these. Let me do 4. Basically, what delete node does is, if I say delete Anambra, it's going to take this out, completely out, and every occurrence of Anambra where Anambra is connected to will be removed. There won't be Anambra here. 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 Let's give it a try. So I want to delete the node Anambra. So I'm going to pick 6, and it's asking me which node do I want to remove. I'll say Anambra. So you say Anambra completely deleted from the graph. So I can go to 4 again to show the connections, and you'll see Anambra is out of this place. There is no Anambra in the keys here, and in the nodes represented by keys, and there is no trace of Anambra at all. And that is what that does. To see these graphically, we use the show diagram. To show the diagram, just do 7, and you press enter. What that does is that it actually creates a file. This file, you can see this folder, this directory. It creates this file for you. So you can take this file and go to your browser, open up a new tab, and paste that link there, that part you copied. So when we paste it there, voila, this is what you get. It actually gives you a full representation of the graph. If you refresh, it's going to try to put it in another way just for you to see, but it's all the same thing, following the same paths, and it's showing you how all the graph connects. And it's such an interactive graph. You can drag around. Maybe you want it to go this way, you can drag it around, and you can also move the whole graph around. So it's very interactive, and then it shows it's directional. That's how we developed it. You can see Sokoto goes to Lokoja. It also goes to Lagos, Lagos to Abia, Lagos to Kano, and all like that. Going back to our code, we can see this also represented here. To show me the nodes, you will see exactly how it is. That let's take a look at Lagos. Lagos is connected to Abia and is connected to Kano. If you look at it here, Lagos connects to Abia. You can see the arrow, and then the arrow connecting to Kano. Now let's do the depth first search. How do you do the depth first search? The first thing is to say, where do you want us to start searching? What is the root element that you want us to start searching from? Let's just do it. When I type 8, it's going to actually do that. It's going to ask me enter the root node. So let's take a look at this. Let's say I wanted to do a depth first search starting from Rivers State. So I'm going to come here and type Rivers. So when I type Rivers, it's actually going to do that, and it's going to ask me to copy this folder path to the browser. So I'm going to browse that folder path. I'm going to leave this and then put that. So you can see right now that from River State, it shows me the depth first search. This is the path, the depth first search for River State. It goes from Rivers to Lagos to Abia to Kaduna to Kano. And like I said, it's draggable, it's very interactive. Let's do another one. Let's say we want the search 8. We want the search to search from, let's say, search from Lagos. So I'll copy this Lagos. I'll copy this one and paste it. Already I have it in my code in my browser. This is the old one, so I'm just going to refresh the page so you see the new one starting from Lagos. So Lagos goes to Abia, to Kano, to Kaduna, to Kano. Now you can see the real graph. Lagos, all the places Lagos. If you do the first search, it comes to Abia, comes back to Kano, and Abia, Kaduna, Kano. So it comes to Abia, then Kano, and from here also it can go to Kaduna. It just does a depth first search. You can see the directions are shown to say. It's not going to Dutse because Dutse, Kaduna, you can't connect to Kaduna from Dutse. There is no, it's not multi-directional. Let's look at the web interface version. Yeah, this is kind of web interface, but you know, the downside is that you have to either hard code it, or every time you run the code, you have to enter the nodes one after the other. The web version has a database and it stores the whatever data you are or graph you're creating. You can actually create different models, different graphs, and store them, and then, you know, come back and view them. Well, it's not in the very complete stage, but at least it gets the job done.